So I've written down tons of factoring examples here. So number one, we're going to start with an easy one to remind you what we were doing. So x squared plus 10x plus 16. So we want two numbers to multiply to give 16 and add to give 10. So you need to know your factors. So what multiplies to give 16? 8 and 2, good. There's other options, but they won't add to give 10, and they add to give 10? Yeah. So we say, okay, and they both have to be positive? Yep. So x plus 8, x plus 2. And that's it. And on the homework, you could FOIL it out to check your answer and make sure you get the right thing, but that's not necessary. If it just says factor, then you just factor. All right, number 2. X squared minus 2x minus 3. We want two numbers to multiply to give negative 3. Now, what does that mean about the add part? We want them to subtract instead of add. So we want two numbers to subtract to give negative 2. Now, forget about the sign. Don't worry about the sign. You say 3. What two numbers multiply to give 3 and subtract to give 2? 3 and 1. 3 and 1. You have to figure out which way the signs have to go. So 3 minus 1 is 2. Now, which one do we want to be negative? We want them to subtract to give a negative 2. So the bigger number has to be negative to end up with a negative. So minus 3 plus 1. Does that make sense? Or 1 minus 3. Does that work when we multiply? Yes. So negative 2. So we say this would be x minus 3, x plus 1. And again, you could FOIL that if you wanted to check your answer. Now, this is a really easy section for you to give someone like a little practice test in, or make your own little practice test. So I'm going to show you my preparing for class, okay? Because these questions are really easy to make up, that they work. So what I do when I make up the questions is this. I say, okay, give me two numbers, 2 and 8. Add them to give the middle number, multiply them to give the last number. So I start with the answer, the two numbers. So here I said, okay, minus 3 and 1. I'm going to add them to give minus 2 and subtract them to give 3. And then I went down my list. I said, okay, well, what if the numbers are the same with opposite sign? Another one. What if they're both negative? Right? Both negative again. And then I sort of modified and then said, what am I missing? Right? But you can easily pick two numbers and then write the quadratic for it. You multiply them to get the last, and you add them to get the middle. Okay? Or you just take the list like I give you in class, write them all down, and that's a whole bunch to practice with later when you have the test. All right, what about this one? Right. Always your first step is to check if there's a common factor. So what's the common factor here? What can we pull out to the front? 3. So if we take the 3 out, remember it's like dividing. So 3x squared divided by 3 is x squared. 12 divided by 3 is 4. Now what you have left, there's a 3 in front. And what you have left is, what do we call that type? Difference of squares. Has to have a minus in between. So difference of squares, leave the 3 there because we're factoring this bracket. The 3 is still there, so this is x plus 2, x minus 2, or minus 2 plus 2 in whatever order, okay? Don't try to memorize what order they have to go in because it doesn't matter. Okay, number 4. X squared minus X minus 20. So we want two numbers to multiply to give negative 20, and do we want it to add or subtract? Subtract. If that number is minus, then we want to subtract to give what? Negative 1. Interesting. What two numbers multiply to give 20? 4 and 5. Do they subtract to give 1? Yes. So 4 and 5, just write the two down and you have to decide the sign. So we want them to end up with a negative. 4 minus 5, a plus 4 and a minus 5. All right, they multiply to give negative 20 and they add to give negative 1. So that would be x plus 4, x minus 5. X squared minus 2x. What do they have in common? The 2x. So factor out the 2x. If we take a 2x out of 2x squared, right, the 2 cancels and one of the x's cancel. Just x. 2x out of 2x? 1. What else? Nothing. That's factored. Like there's no squared anymore, so that's factored. We would be done. So common factor, you can have just a common factor. So try that one. Pull out what they have in common. Sort of the same idea of what we just did. And then look at what's left once you pull out what you have in common. Who's 100% confident with their answer? I'm not going to ask you, so you can raise your hand confidently, knowing that I'm not going to call on you. Only 2 people are confident with their answer? Oh, there we go. Okay, who thinks their answer's wrong? Don't think you're wrong. So 3x, what would we have left? X squared minus just 2. Right? 6x divided by 3x. The x's cancel, and a 3 cancels, and 6 is 3 times 2. So just a 2. Now this is iffy, right? But I showed you how to factor that. It is a difference of squares, and you would go farther if there's an x squared, and it can factor even if it's not nice. So you do go one step further with that. So what is the difference of squares? How do we do that if 2 is not a perfect square? Yeah. Plus root 2, minus root 2. Okay, so you would do that. All right, so some people that didn't raise their hand were not sure if they should go further or not. Is that right? Good. Okay. So the answer is yes, you should go further. Okay. What if there's... Because the difference of squares you have to take, just like up here at the 4. So when you have a minus in between, you do the square root of 4, which is 2. Do you see it? So when we have this one, the square root of 2 is root 2. It doesn't work. It's not a perfect square, but we still want to factor that one step further. Okay? Because whatever you're using this for later, you need the answer plus or minus root 2. You need those. You can't stop before and say there's no answer, because there is an answer. It's just that it's not nice. It's not a whole number or an integer, right? But it's still a number. root 2 is 1.17 or something, so it does have an answer. So you do want to go further. Okay, 7. All right, so there's a common factor here, which would be what? 2, yeah, they all have a 2, and they all have, how many x's is the most? 2, so x squared, so they have a 2, x squared that we can pull out. So 2x squared here, the 2 cancels, there would be x squared left. Plus, take the 2x squared out, in the middle term we'd have a 2. And an x. And out of the last term, the whole thing, so 1, yeah. All right, so the question is, I don't have room on the page, but the question then you say to yourself, well, there's still an x squared. Actually, there's 2. Can we factor it further? So here you would try this. Now they don't always factor, so we'll see some that don't factor in a minute, but they don't always factor, but what would we look for here? 2 numbers that multiply to give 1 and add to give, because that's positive, add to give 2. 1 and 1? 1 times 1 and 1 plus 1? So this would be 2x squared on 2. 1 and 1, so x plus 1, x plus 1. How could we write that? X plus 1 and x plus 1 are the same factor, just written twice. Yeah, so we can put it as one bracket with a squared. Hopefully you have more room just to write this underneath, but I'm going to write it beside. So you can write the answer that way. Either is okay. It doesn't matter if you shorten it or not, but they are the same factors. And this x squared, we don't factor further. It's just an x squared, so it's not plus or minus a number. Okay, so this one is a sum of squares. And a sum of squares does not factor. Okay, so a difference of squares does, plus or minus whatever the square root is, but a sum of squares does not factor. Now, basically the idea is this: if you were trying to solve this for x, if you want some number plus 4 to equal 0, what would that number have to be? Don't think too hard. Something plus 4 equals 0. What would that something have to be? -4. Can you square a number and get -4? No, because what happens when you square a number? It becomes positive. So you can't square a number to get -4, so this is not going to work. So it has no solution if we were solving, which we do later on in 1.8. We solve these. But right now, it doesn't factor. Okay, and why it doesn't factor, it doesn't have a solution, it can't break down further. Okay, so you have to remember that and not do something funny with it. Okay. So here we want 2 numbers that multiply to give 3 and add to give 3. So what numbers multiply to give 3? 3 and 1, that's the only option. What do they add to give? 4. And if you're worried about subtracting, what do they subtract to give? 2. So they add to give 4, they subtract to give 2. Is there any other options? Is there something else that multiplies to give 3? No. So we would say this does not factor.
So technically that already is factored?
Well, yeah, I guess you could say that, it's already factored. Or it's factored as far as it can go, that, yeah. Factor usually means something's multiplied to give it. If I did this, you see, okay, so I wrote a new question here. They have an x in common. So if we pulled out the x, I end up with that doesn't factor. So this we would say is factored as far as you can go. You end up with an x squared, but this doesn't factor. So this is factored as far as possible. Okay. Yep.
That's been factored as far as it can go, and when we decide to use the quadratic equation?
Excellent question. You only ever use the quadratic equation when you're solving an equation. So it has to say equals 0. And in this section, we have none of them are equations, so we're not actually solving for x. So you use the quadratic equation only when you're solving for x, not when you're just simplifying. Okay? So that's a good question, because you don't, and if you were solving for x, if this said equals 0, then you would try the quadratic equation, right? This is, I put does not factor. That doesn't mean it has no solution if it were something we were solving for x, right? It doesn't mean there's no solution, it just means we can't factor it, okay? It doesn't simplify further. Okay, so you have to be careful of those kind of words. This is just, it says factor, and you said it does not factor. Right? You don't say there's no solution, because we're not looking for a solution, right? When you're saying solve for x, that's when you're looking for a solution. Always has to have an equal sign. Equals 0, equals something, okay? Okay, so this one I would say to myself, yuck, I don't like factoring these ones that have a number in front of the x squared. But before you say yuck, say, does the 3 factor out? No. So then you can say yuck. All right? So how do we do these ones? It's a little bit different. We say multiply to give, instead of just the -6, what do we say? Multiply to give 3 times -6, whatever that is, which is -18. So we need two numbers that multiply, and I got those here, 3 and -6. Multiply the first and the last. That gives -18. It's a negative, so we want to subtract to give 7. Positive 7. All right, so we need to think about what multiplies to give 18. 2 and 9, does that subtract to give 7? Yeah, excellent. There could be other options. What else multiplies to give 18? 3 and 6, what do they subtract to give? 3. So you'd say that doesn't work. Just in case you didn't think of 2 times 9 at first, if you thought of the wrong thing. What else? 1 and 18, they subtract to give 17, so that's no good. All right, so we're saying 9 and 2. Don't put the signs on, just put the numbers. We want them to subtract to give a positive 7. So which one has to be, the bigger one has to be positive to get a positive answer. So 9 minus 2 gives positive 7. And that would be positive 9 and minus 2. Multiply to give negative 18. Okay, now we don't, that's not our answer. We don't just put those in a bracket like the last ones. We rewrite this, 3x squared. Instead of the 7x, we put plus 9x minus 2x. So that's your 9 and your, minus 9 and your 2. Plus 9 minus 2. That gives that. Right? Now do you remember what we do next? Break it into 2 and factor them separately. So we factor this one. What factors out? A 3x. What's going to factor out of this one? Negative 2. Always take the negative if it starts with a negative, okay, that's a good tip. All right, so if we factor out a 3x, we're left with an x, plus 3, plus, or minus 2, sorry, minus 2, factor that out, x plus 3. Now, if you didn't take the negative, what you would have is minus x minus 3, and you'd say, that's wrong, because how did I know that this is on the right track? These two are always the same. If they're not the same, you messed up somewhere. Okay? Maybe you had the wrong two factors, or maybe you put the sign backwards. Okay, if you messed up somewhere, these will not be the same, and if you didn't, they are. Now our factor is 3x minus 2, and x plus 3. X plus 3 and 3x minus 2. Those are our two factors. So what do we do here? Do you see anything in common? By the way, we're not doing factoring cubes and fourth powers, although that is something that you will have to learn at some point, and if you go on in math. It's by synthetic division or polynomial long division. We're not doing that in this class. So that being said, anytime you see an x cubed, there is a common factor that comes out, or an x to the 4 or an x to the 5, okay? So there's not a special way that we're factoring those. If you see an x cubed, a common factor will come out. So what is the common factor of this one? X. So we have 4x squared plus 3x minus 1. So then you say, yuck, that is a 4 in front of the x squared, but we have to try to factor it. So what do we want? Multiply to give minus 4. 4 times minus 1. So we want it to multiply to give minus 4, and we want it to subtract to give positive 3, the middle number. The x is already factored out, so this is partially factored now. We're just seeing if this rest of it will factor. Because it's still an x squared, it might. Two numbers that multiply to give 4. 4 and 1. 4 and 1 subtract to give 3. We want it to be a plus 3, so we want a plus 4 and a minus 1. So we would rewrite this 4x squared. Instead of plus 3x, we're going to say 4x minus 1x plus 4x minus 1x. And you don't need the 1 there. I still have the x in front, although you could do it off to the side and then bring it back in, but I like to just keep writing it if it's not too long. All right, so here we go. I'm going to do it in a different color. We're going to factor these in parts. What factors out of this? 4x. So we'd be left with 1x plus 1. And what factors out here? Negative 1, x plus 1. Factoring at a negative changes the signs. Are these the same? Yep. So our answer is 4x minus 1 times x plus 1. That bracket's kind of big. So this has three factors. One of them is x, 4 minus 1, and x minus 1. You could FOIL this out. How do you FOIL this out to check your answer if you wanted to? Yeah, there's three factors, so you have to do two of them first, and then you can multiply by the last one, okay, in any order you want. So if we were going to check our answer, You could do the x in first, and then multiply by x plus 1, or you could do these two multiplied to give the x. Let's do it this way. 4x squared minus x, and we still want to multiply that by x plus 1. 4x cubed, 4x squared, minus x times x minus x squared, minus x. Collect any like terms, so minus 4x squared minus x squared is 3x squared. And is that what we started with, the original question? Yep. Okay, but again, that's just a check, right? It's not part of the question once you factor it. If you're confident in your factoring, you don't need to check it, but on a test, if you have time, it's always good to check your answer if you can. Okay, a couple more. Let's see. What number was that? 11? Okay, so there's a 5 in front of the x squared, but don't say, yeah, I can tell you check that it doesn't have a common factor. And does this have a common factor? It does. I put this one on purpose when I was preparing this morning because on the test there was a question like this. This is the cube root of 8 to the 4th power. I know this doesn't look related, but the other question was, it had 5s in it. What's the cube root of 8? 2 to the 4th power? Yeah. Now, one of them was 5 cubed, one of them was 2 to the 4. This is 16. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. This is 16. One of them was something like 25, the square root of 25 cubed. This is the square root of 25 all cubed. Square root of 25. 5 cubed. 5 times 5. 25. 25 times 5. Think money. If you had 5 quarters, how much money do you have? You don't need to write that out. If it's 25 times anything, usually you can think about money and figure that out. It's 125. Some of you did some pretty complicated things for this particular 2-line question. So the important thing to notice was that if you have the 4, you don't do 8 to the 4. You do the cube root first and then do it to the 4th power. Right? Same here. If you can take the square root, do the square root first and then cube it. These are equal. Doesn't matter which one you do first, the power or the root. Okay, so taking out a 5. 50 divided by 5? 10. 125 divided by 5? 25. And now there's not that number in front of the x squared. So this is, if it factors, is one of the easier ones. We want it two numbers to multiply to give 25 and add to give 10. 5 and 5? 5 times 5 is 25. And 5 plus 5 is 10. Right, they add to give 10 and they multiply to give 25. And we could write this as a perfect square, they call it, when you have a factor that's the same factor twice. Okay, what other ones do I have here? X cubed minus x. Okay, you do that one. Okay, so I've got a second one here for you to try. Same method, you're gonna do a common factor, and then if there's a squared left, you either factor it or you can't. So here's 2. And then I'm gonna add one last one. Okay, there's 3 there. I want you to try all 3. See how confident you are with your answer. Who has them all right? Oh, good. Good. Okay, so the first one, an x factors out, and we'll be left with x squared minus 1. X squared minus 1 is a difference of squares. So x plus 1, x minus 1. Just look at your answer and make sure it looks like mine. 3 factors here. Starts with a cube. There's either 3 factors or 2 or 1. And it can't be more than that. What about the second one? An x factors out again. X squared plus 5. Sum of squares doesn't factor, so this is done factoring. That's it. You would just stop. You don't say doesn't factor, because it did factor. We factored it. We're done factoring. Okay, it doesn't factor further, but that's not something you need to say. You just need to know that you're done factoring. So this does not factor further. It doesn't mean no solution, because we're not trying to solve anything. Okay, so be careful of that, not writing no solution. We're just factoring, and we're done factoring. What about this one? So x squared minus 2x minus 8. So either that factors or it doesn't. We want 2 numbers to multiply to give negative 8, and so because that's negative, we're going to subtract to give negative 2. 8, 4, and 2? No, because what we're trying to do now is factor this part. That x was already factored out. So now we're trying to factor the new polynomial. So 4 and 2 give 8, and they subtract to give 4 if I do this way. Or subtract to give negative 2. If one is negative and one is positive. So this will be x. You don't want to forget it, because this is going to have 3 factors. X minus 4 and x plus 2. In whatever order you want. Okay. So what we do next in the next section is still factoring, but we add fractions into it. So what does that mean? We have to factor the top and bottom of a fraction, and then if they have a common factor, they cancel. We have to do common denominators, group the terms, factor the top and bottom, and if, right, so it's like adding to it. Still not solving though, just simplifying.